So that is data integrity. Okay. So the fourth one will be your. So these are the different terms that we use in security mechanism. So we can start like this, that why we require this security mechanism, just to detect, secure, or prevent, or just recover from any type of attack or any type of a security attack. Okay. Now there are some terms that we are using here, that is encipherment. Second is your digital signature. Third one is your data integrity. Okay, so I will write again here, that is data integrity. Fourth one will be your authentication exchange. Authentication exchange. Next will be your, that is traffic padding. That is traffic padding is there. Next is your routing control. Like routing control is there. Next is access control. And last one will be your notarization. So that will be your notarization. So these are some of the terms that we use in security mechanism, or we can represent it as a, these are some of the terms that we or methods that we use while using different mechanism in order to secure a system. So for what particular purpose we require all this mechanism, just to may ensure that whatever the system on which we are working, it should be protected, or if it has been affected, that how we can recover from that particular effect of that particular attack. Okay, on how we can prevent all those things. Fine. So this is the security mechanism. These are the different terms we use in security mechanism, or these are the different tools that we can have. So we will discuss one by one each tool. So very first one is the first method is that is the encipherment. So what we mean by that encipherment, that it converts the plain text to the ciphertext. Okay, so encipherment, it is the technique in which we are just converting the text that is in the form of a plain text to the ciphertext. Now here what will happen, that we will be using different mathematical algorithms here. Okay, so with the help of different mathematical algorithms, we will be converting that particular plain text to the, we will be converting different plain text to the ciphertext part. Okay, so this is the use of a different mathematical algo we can have, that is not readily not easy to be recover from. So what we want, that we will be converting our plain text to the ciphertext. Okay, we will be performing such type of a algorithm on that, so that whatever the conversion that we have applied on the plain text should not be easily be recovered while we are transmitting that particular data on that. Okay, so this is the encipherment, that we are converting the plain text to the ciphertext over here, right? Next method is that, now there are so many techniques that we can use for the same, like we can have encryption is there, we can use the method of encryption. Steganography will be there. Steganography will be there, that we will be discussing shortly when we will start with the different algorithm techniques in this particular subject. Okay, next method is that digital signature. Now, as we all are aware with the term signature, so signature is anything that we are giving just authority that the particular thing or a product is being used by me. Okay, but we, in terms of, when we talk about in terms of a we say that e-marketing, or when we talk about that digital equipments, or the various things that we are using digitally, in that case we prefer a word digital signature. So at that particular time, we are not doing any manual signature on the documents, but we use the term digital signature, that is also known as a e-signature also. Okay, so this is also one of the mechanisms that we can use. So digital signature is basically a mean by which the sender can electrically sign the document. So we are electrically signing that particular document over here. Electrically signing the document, that is the part of your digital signature. Clear? So that is the part of your digital signature when we are electrically, we are signing that particular document. So that it should be and the other end. So user will sign that document electrically, and also the receiver end, it will check that whatever the signing that has been done by the sender, it is true or not. So that also confirmation will be also there at the receiver end. So we will be doing so much in detail when we will move further in this particular subject, that how digital signature works, what are the different means are there, and how we can develop this digital signature also. But meanwhile, you just understand that what are the different mechanisms that we can use in order to just research how we can protect the particular system. Fine. Next term is the data integrity. So the first was the encipherment, in which we are just converting the plain text to the ciphertext, where we can perform various encryption algorithm, or we can use the concept of that signography also, that we will be discussing shortly. And second was the digital signature, in which we were electrically signing that particular document, right? So what we want, so here what we are doing over here, that we are electrically signing that particular document. Third is the data integrity. So as the term specify, integrity is what, that is not changed, that is not altered in between while you have sent that particular data from the sender to the receiver. So here, what we will do in the case of this e-media, that we will be following this data integrity by using the concept of check values. Okay, so we will be using the concept of the check values over here. So we will be having some particular check values. So what this check value will do, it will just see that we have different checkpoints in your message. So what will happen when your message will be received by the receiver, it will just see that whatever the checkpoints that the sender has told you, at that particular point, all these check values are available. That will confirm us that whatever the message that has been sent by the sender, it is being authentic and it is not being modified in between while the transmission of that particular message. Okay, so this is the main meaning of this data integrity. So integrity means that we need to check just need to say that whatever the content that we are sending to the sender to the receiver end, it has not been altered anywhere in the meantime. Okay, so that is the check value. So this is so what will happen? So like there is a sender and here we are having that receiver. So sender will be having that different check values. Okay, so receiver will just compare all those check values. Okay, so we will be providing some prior information to the receiver end also, that we have that different check values at this particular place. So what the receiver will do, it will just compare all those check values. Okay, so receiver will be comparing all those check values, and if the value remains the same, that means that message has not been altered while transmitting. Right? So this is how we can define a term. So this is how we can define a term that is a data integrity. Next term that we are having here is the authentication exchange. Okay, so next term that we will be having over here, that is the authentication exchange is there. So in this, so as the name suggests, authentication exchange. So here both the parties, both the sender and the receiver will send some particular message, authentic message. Okay, so many times you have seen that when we are signing up for some particular new account, so it will ask us some different questions for the same, like what is the name of your pet, which is your favorite country, which is so many questions. So these are the authentication exchanges is there. So that in future, if you just forget all those details regarding your particular account. So obviously your choices don't change frequently. So it will ask you again the same questions. So it will compare that whatever the answer that you are currently giving is being matched with the previous answers or not. Okay, so that is the concept of authentication exchange, that it will send you some authentic, both the parties will send some authentic message to either each other, just to ensure that both the parties that is available on that particular network is the true person or not. So that is the concept of the authentication exchange. Okay, so two entities will be exchanging some messages to prove the identity. Okay, so they are just in a mode that they just want to prove their identity. So we can write like this also, that they can be to prove identity to each other, prove identity to each other. They are exchanging some messages. They are exchanging some messages. Right? So this is the concept of authentication exchange. Okay, so this is the concept that we can write like this, that what is authentication exchange, that will prove some identity. In order to prove their identity, they will be exchanging some messages. Right? Next is the traffic pattern. Okay, so next case is the traffic pattern. So what will happen here, that in this particular technique, we will add some extra or a dummy bits. Traffic padding. Padding means that you are adjusting something, you are adding something. Okay, so we can write like this, that we will add some extra or dummy bits with the data while encrypting. While encrypting. So here traffic padding means that we will be adding some extra data or extra bits or a dummy bits with the data while encrypting. Now, what is the purpose of this extra padding? The purpose of this extra padding is that it will just ensure that whatever the extra element, dummy elements you are sending, it is being received at the receiver side or not. Okay, so it will just check all those that I have already sent you these extra items with you, a gift item with you, or some extra bits to you. So just kindly confirm that you are getting that particular data. Okay, so that is a part of your traffic padding. Fine. So this is how we can write like this. So traffic padding is what, that it will add some extra or a dummy bits with data while input. Next is that routing control. So here what will happen, that we will be having some different means of selecting and continuously changing different routers. Okay, so routing control is that we will just control all those routers on our network, because every anything that we are sending, that is all available on the network part. So routers is one of the major component of your network area. So here what will we be dealing with? That we will be just selecting and continuously changing different available routers between the sender and the receiver. Why so? So that the third party or the hacker should not able to get your message. But what is the purpose of using this routing control? But that means that every time when we need to send the message between the two parties, we will follow a different router for that. Because there could be a hacker that is just following the concept of that eavesdropping, or it is monitoring your particular network. So it will just resist that particular, we are just fooling that particular third party, or we are just misguiding that hacker or a attacker, that won't be able to, we are not following the same route every time when we are sending that. Fine. So that is the concept of this routing control. Okay. So routing control is what? That is changing, selecting and changing different available terms. So selecting and changing different available objects. So this is the funda of this routing control. So this again, why we require this? Just to misguide the attacker or the hacker that we are not following the same that is a traffic pattern, or we are not following the same route in order to send the message from the sender to the receiver. Clear? So this is the case where we are using this routing control. Next is the access control. Okay, so the next mechanism is that is the access control. So these methods prove that the user has access right to that particular data. Okay, so we can also use one of this type of security mechanism where we will use some access permissions are there that will allow that particular user only to access that particular data. Okay, either by giving some particular password or giving some different methods, we are just giving the rights to the particular user that you are only having the right to change or to receive that particular type of it. So that is the part of it, access control, which proves that a user has access right to the data. Access right, user has access right to the data. Okay, that is the access control. Right? So this is the another mechanism that we can follow, security mechanism, while we are working in a network in order to transfer data from one place to the another. Next is the notarization. Okay, so what is means notarization? Like we have a notary officer over here. Okay, so similarly we follow the technique of notarization. So what is the purpose of the notarization? That we will use some third party authentication. So what will happen in that case of the third party authentication? That we can say like this, that whatever the sender is sending the data, so that will be the duty of the third party to authenticate that the sender is the right person and whatever the content it is sending is also right. Okay. Similarly, to the receiver end also, the third party will authenticate that whatever the receiver is that receiving that particular data is the right person, and also the data that it has been received, it is being in the fully confidential mode and it is not being modified in between. Okay, so that is the purpose of this third party, that is the notarization. So in the case of a notarization, so we have a third trusted party to control the communication between two entities. We have a third party, trusted third party to control the communication. To control the communication between the different entities. Okay, so why we require this? Just to have a authentication model between the two parties. Okay, so that will trust the third party that this particular person has confirmed me that, or this particular party has confirmed me that whatever the two entities are there, that is at the that are the true identities, and it is not working as a false worker on while transmitting that particular. That is the purpose of notarization. So again, I will just explain in brief that what basically a security mechanism is. So security means that when anything that we need to protect, and mechanism are the different methods that we can do. So what methods we require, how we can prevent, how we can secure or recover if some particular attack may happen on the system. So that comes under the security mechanism. So we have discussed total 8 techniques over here. So one is the encipherment, in which we are just converting the plain text to the ciphertext, and we will be following different encryption algorithm over here or some signography techniques. Fine. Next is the digital signature is there, where we are electrically signing that document. What is the purpose of the digital signature? Just to authenticate that whatever the sender that has sent to us, it is being fully authorized to that particular person. Okay, that is the digital signature. Similarly, we have a data integrity over there. Integrity means that we just want to confirm that whatever the data that we are sending, it is not being altered in between anywhere while the transmission. For here, we can use some check values over here, and the sender can add some particular check values, and receiver can check all those check values just to confirm that whatever the data that has been sent is, it is being true. Then is a authentication exchange, that is to prove identity of each other, that what will they will do, both the sender and the receiver will exchange some particular messaging just to ensure that both the parties are the correct parties. Next is the graphic padding, in which we are adding some particular data, extra data or a dummy bits we are adding with the data. What is the purpose of that? Just to ensure that whatever the data that we are transferring, it is the right data. Routing control is there, that here we give the option to the user that they can select or change the different available options. Okay, why it requires, so that if we feel like that if there is any hacker or attacker that is monitoring our network, so just to misguide that. Next is the access control, in which a user has access right to the data. Okay, we will give some special permission to the user. That particular user can access only that particular. And next is the notarization, which will in which we are having the trusted third party that will just confirm that both the entities are the true identities, and it will help us in the right transmission between the two ends. That is the sender and also and the receiver. So I hope you are clear with this particular security mechanism. And now we will move further to another topic. Okay, next topic is that is OSI security architecture. OSI security architecture. So this is open system interconnection. OSI is what? That is an open system interconnection that was designed by ITUT. Okay, so it was designed by ITUT. That is International Telecommunication Union. Okay, and T is again for the telecommunication. So what ITUT recommended, that it recommended on its recommendation, it has recommended X.800. Okay, so this is the security architecture for OSI. This is the security architecture for OSI. Right? So OSI security architecture is basically designed by ITUT, that is we can say that International Telecommunication Union, and again that T is for the telecom. So it has designed that X.800 security architecture for OSI. So what it defines a systematic approach. It defines a systematic approach. Okay, so that is useful for providing security. Useful for providing security. Right? So it will define some systematic approach. Why we require this particular OSI security architecture that has been designed by ITUT, just to provide a systematic approach to provide the security part. Okay. Now, how we can provide this particular security part? So for this, it has developed that particular standards. It has developed standards, recommendations, and the recommendations are there. So that relating to telecommunications, relating to telecommunication, telecommunication, and to the open system exchange. That is OSI, open system interchange. Fine. So OSI security architecture basically was designed by ITUT, and on its recommendation, it has developed this type of the security architecture. So if somebody asks you that what type of a security architecture you follow for this oversight, so its name is X dot 80. X is, we are defining it as a versions for that. Okay, so it will define some systematic approach that is useful for providing security. Okay, so it is also giving some standards here and some recommendations are also there. Apart from that, this oversight security architecture basically it focuses on security attack. Okay, so it works on security attack, security services, and security mechanism. And security mechanism. Okay, so it focuses on security attacks, security services, and security mechanism. Right? So these are the three things that we have already done. That we can say that what type of a security attack we can have. Okay, so services what that what particular that security of it that particular processing system is having. Okay, and how we can protect that particular system. And mechanism is the way that it provides you that how we can detect, recover, how we can just detect, recover, or prevent that particular security. Okay, so this is a general discussion on that how this overseas security architecture works. So just remember one thing that we require this X.800 model for that. That is providing us the different systematic approach that is useful for providing the security. Okay, so it basically consists of security attacks, services, and the mechanism. Yeah. Next is that. So next is the model of the network security that we need to follow. Okay, so we can just now the next thing that we will discuss over here, that is the model of network security. Okay, so next thing that we will discuss here is the model of network security. So what model basically we follow for network security is that model for network security. Right? So here we can start with like we had a sender part, and here we are having the receiver part. So sender is there and the receiver will be there. Now what will happen? The sender will be having some particular message here. Okay, so sender will be having some particular message here. Okay. So what will happen? We can perform various security related transformation flow. So we can just follow various. We are just following various security related transformation. Related transformation. Security related transformation. We are following various security related transformation over here. Why so? Because we are having some secret information. We are having some secret information. Okay. So we are following some security related transformation on this particular secret information. Fine. Now, after doing all these transformations, now we have the secure message. So we are having a secure message here. So we will be having a particular secure message will be here. Fine. Now here we are having the information channel. This will be your, we can see that information channel will be there from which your information is being passed. So this is your information channel we are having. So that is information channel. So again, this message will pass from this information channel and you will get that particular message here. So we are getting that secure message here. We are getting that secure message here. Again, on this particular secure message at the receiver side, we will again perform that security related transformation. So again, we are having that security related transformation. Security related transformation. Okay. So when you will transform, use a different transformation technique just to receive that particular message. So finally, you will get that message here. You will be getting that particular message at the receiver. Okay. So again, your secret information will be available at this particular point. So you will be getting that secret information at this particular point. Is it fine? So this is the main model of network security, that obviously when we need to transfer some particular message. So two entities are very important. One is the sender and another part is the receiver. Now sender is what that is sending that particular message, and we are sending that particular message and we are providing all those transformation on that particular message. Fine. We are performing all the security related transformation of that particular message, and here that means that message will now become a secret message for us. Okay, so that message will become a secret message information for us. So again, we will just encapsulate that as a secure message. We will transfer this particular message to the information channel, and at the receiver end, we are getting that secure message. Okay, so we are getting that particular part. So we are getting that particular thing on that we are it will transfer to that information channel, and again we are having that secure message. Okay, so that we will be receiving that particular secure message and we are getting that security related transformation. Again, we will convert that particular, do all those transformation, and we will be having that secret information. Okay, fine. So the secret information will be again that we have recovered that particular original message that we have already transferred from the sender. Okay. So these are the major entities in a network security part. Apart from this, we are also having a trusted third party. So we are also having a trusted third party here. Okay, so we will be having that trusted third party here. That is just monitoring the communication between the sender and the receiver. Okay, so that is monitoring the transmission of that message from the sender to the receiver. So we are also having that trusted third party. Okay, so trusted third party is a distributor, could be distributor of your secret information. Okay, it could be administrator of your information. So we can refer it like that. That it could be distributor, it could be just an administrator. That is just monitoring whatever being transferred. Is it clear? So this was all about that how we can define this particular this is security method. Okay, so what basically model we are following for the network security. Okay, so all these techniques will for providing security have two components. One is the security related transformation, and the another part is the two basic components that we require. Here, you just remember, two components are required here. The very first one is the security related transformation. On the security related transformation on the information to be sent. This is the first component. Second component that we require that some secret information shared by the two parties. Okay. So some secret information shared by two parties. Okay. So these are the some major components in this network security model. So the very first thing is that what type of a transformation we are doing on that particular list. Okay, this is the first thing that we require, and the second thing is that what type of the secret information we are sharing. So at what particular intensity that we are sending that particular information, that is also required. Okay, so these are the major we can say that components that we require. So in the case of this network security. Okay, so here also with continuation of this particular diagram only, so we can just represent that. You just keep this diagram in your mind, and you just remember that what basically task is occurring. Here, basic four tasks are occurring here. So the very first one is that we need to, so we can define four tasks. These are four tasks in designing a security service. So if you need to develop some particular security service for a particular network, what are the major tasks that you require? Okay, so basically we require these four tasks here. So the very first one is the designing of algorithm, design and algorithm for performing security related transformation. Security related transformation. Okay. Next is that we need to generate the secret information. Generate secret information to be used with algorithm. To be used with algorithm. Okay, so first is these are also two are the major components of a network security model, but still we can design like this. We need to design an algorithm for performing security related transformation. Second is that we need to generate secret information to be used with algorithm. Okay, to be used with algorithm. To be used with algorithm. Third part is that third part that we need to develop methods for sharing and distributing secret information. So this is also we require. So we need to develop methods that how we can share and distribute that secret information. This is the third task that we require. And the last part is that we require to specify a protocol to be used. Okay, so we have to define a protocol to be used between sender and receiver. Okay, so this type of a question is quite important, that if you need to develop some security model for a particular system that is available in the network, so what different tasks you have to, what are the different basic tasks that you are must undergo before the design. So these are the basic four tasks that we require in order to design a particular security service. So the very first one is that design designing of an algorithm for performing security related transformation. So algorithm is required here. Then we require the secret information, that is we need to be used with this particular algorithm. Next we require to develop methods for sharing and distributing that particular secret information. Fine. And last thing is that we require that we need to specify a protocol to be used between the sender and the receiver. Fine. So these are the basic four major tasks that we require. Okay. The next thing that we will discuss here, now we will start with the algorithms part. Okay. So we are now here with what basically security model we use, what are the different mechanisms we can have, what are the major components of any security model that we are using for any type of a organization. Okay, so now we will discuss, we will now starting with the algorithms part, that is the most important part in any type of a security. So in that particular algorithm part, we can just get on that what method we will be using, how the method will be performed, how we are changing that particular data just to securely transmit it from the sender to the receiver. Okay, so now here we start with the classical encryption techniques. Okay, so we start with the classical encryption techniques. Classical encryption technique. In this particular classical encryption techniques, we mainly follow a symmetric cipher model. Okay, so what model we will be following here? That is a symmetric cipher model. So we will be using that symmetric cipher model. So we will be using this symmetric cipher model here, and this is a symmetric encryption scheme has basically five main components. So this symmetric cipher model will be having five main components over here. So it is having five components. So the first one is plain text, plain text, encryption algorithm, encryption algorithm. Next is the secret key, secret key. Fourth one is the cipher text, cipher text, and the fifth one is the decryption. Decryption. Now these are the five major components that you will be getting in any type of a model. So if you are following any type of encryption technique, you will be getting these five components each and every time while implementing that particular algorithm. So these are the basic five components that if you are following any symmetric encryption method, or if you are following any symmetric cipher model for just to transfer your information from the sender to the receiver. So at that time, you will be getting these 5 components each and every time. Okay. So the very first part is your that will be your plain text. This means plain text is what? That is the original message. So whenever we come to the term plain text, that means we are defining the original message over. Original message. So whenever we are using the word plain text, that means we are defining a original message here. Okay. Next part is the encryption algorithm. So it is not here, but you just listen to me clearly. That this is encryption algorithm. So what we are following, that is the encryption algorithm. So what is this encryption algorithm? That will perform various that will perform various substitutions and transformation. Transformation on plain text. Okay, so it will be following all those substitution and transformation on plain text. That is the purpose of this encryption algorithm. So anytime when you will get this word encryption algorithm, that means you are performing something on your plain text. You are just changing your message, original message. You're just changing in such a form just to hide the content of your message. So either you will be performing some substitutions over there, or you will be performing some transformations over there. Okay, so whatever the technique that you are following, just to hide your original content over here, that will occur under this part, that is a encryption algorithm. Fine. Next is your secret key. Next main component is that is the secret key. So now the secret key is also the input to the encryption algorithm. Input to encryption algorithm. Okay, so its key, the key is a value independent of plain text and of algorithm. Now this particular key will be independent of plain text and the algorithm. So this key will not be dependent on any algorithm or the value or the message that you are originally defining in the plain text. Okay, so this key is secret key is one of the input to the encryption algorithm, and it is also independent of the plain text and the algorithm. So you can say like this. So you can see like this that this particular key is not dependent on any type of algorithm. Right? So this is also the main part of the secret. Next is the ciphertext. Okay. Next is the ciphertext. That is a scrambled message produced as output. Scrambled message used as output. Scrambled message used as output. Okay, so this is our what is ciphertext. So you must also define this particular term. That how we can define a particular term ciphertext. That is a scrambled message that is used as a output. Okay, scrambled is what? That you have just changed the original content of your message. Fine. Next is your decryption algorithm. Okay, fine. So next thing that we are having, that is a decryption algorithm. So this is the particular algorithm, encryption algorithm that will run in the reverse form. So we can define it like this: encryption algo in reverse. So why we are doing this decryption algorithm? So in order to produce the original plain text. So what will happen? It will take ciphertext and secret key, and it will produce you the original plain text. Okay, so it will be taking your ciphertext plus your secret key, and finally it will be producing you with the original text over there. Now, this is the main how we can define a classical. We can say that symmetric algorithm will be worked. So it will define your symmetric cipher model that will be consisting of these 5 components over here. Okay. So one is your plain text, another one is the encryption algorithm. So plain text is what? That is your original message. Encryption algorithm is what? That performs some substitution and transformation on plain text just to hide the content while transferring it on the network. Third one is the secret key, that is the input to encryption algorithm, and it is independent of the plain text and the okay, that is the input to encryption algorithm, and it is independent of your plain text and so secret key will be having its unique value. It is not dependent on any type of algorithm or any type of the value of the plain text. Fine. So next is the ciphertext over here. So ciphertext is what that is a scrambled message. It is used as the output, and here in the decryption algorithm we are performing on that same encryption algorithm but in the reverse form. Okay, why in the reverse form? So that we can get the original message. So here you can see like this that it will be taking your ciphertext and your secret key, and finally it will be producing you the plain text. Fine. So this was all about that particular model that we are working upon. That is a symmetric. We can say that symmetric cipher model is it. Okay. Now, so this was all about today's sessions.